Look at the last question 25. In the figure below, US, UT are line segment each of length 2 units. Right? Therefore, in this case, can you see that this is 2 unit, this is 2 unit, right? And then the angle TUS is 60 degrees. Or therefore, this part here is 60 degrees, right? And then the arc T, this arc TR, this arc TR is 1/6 of a circle. Can you see that the circle is actually partitioned into 6 parts? That means in this case, partition into 6 parts. All right, and then 6 part means what? Therefore, can I extend? Can I extend to here? Can I extend? Or can I extend? All right, is 1/6 of a circle. That means this angle is actually 60 degrees. Because this part will be 60 degrees, right? Because your circle is partitioned into 6 parts. And then this is also 60 degrees, right? Then they say, what is the area of the region? Therefore, once you extend, you know that this triangle is actually what is a equilateral triangle. And because of that, you know that this is 2, this is 2, this is 2, this is 2, right? Yeah, and with that, isn't that you can calculate the area of the triangle? Okay, now in this case, can I call this A and B? Or can I call this A and B? Therefore, you basically get an equilateral triangle. This is A, B, and U, right? And then this is 4, and then this is 4, right? Therefore, I think you can find the perpendicular height. Right? This will be 2, and this will be 2, right? And then the perpendicular height, can I call it H? Because I don't want to introduce other trigo formula. Therefore, I just ask you to calculate H. Therefore, H squared is actually 4 squared minus 2 squared, right? And in this case, H squared is basically 16 minus 4, and that will be 12. That will be 12. And in this case, H, we know that 12 is actually 2 squared times 3. Therefore, this is 2 square root 3. When you take square root, this is H. Right? Therefore, the area of triangle AUB will be just equal to what? Will be just equal to half times the base. The base is 4, and then the height is 2 square root 3. 2 square root 3. Therefore, what you get is 4 square root 3. Therefore, I think we are done. Then, can you see that? Isn't that this is what we call the area of the sector? This is part of the area of the circle, right? Therefore, in this case, can I look at this particular part? This is what we call sector. Therefore, let me draw again. This is what we call sector. Therefore, can I calculate area of sector? And let me name this sector as BTR. BTR. That means in this case, I am looking at this sector. This is 2 unit, this is 2 unit, and this is actually 60 degrees. Or you can use proportionality. That means this is actually 60 divided by 360. Then the full circle is actually pi r squared. That is the area of one full circle, but it's only 1/6 of the circle. Therefore, this is 1/6, and then this is 4 pi. Then this is 2/3 pi. 2/3 pi. But you got 2 sectors, right? This area is same as this area. Right? Therefore, the area of the region, area of the required region, that will be what? That will be just equal to the area of the triangle, which is 4 square root 3 minus 2 times the area of this sector, right? Therefore, 2 times 2 pi over 3. Because don't forget, these sectors, this sector here is same as this sector here, right? And that will be just equal to 4 square root 3 minus 4 pi over 3, or 4 pi over 3. Therefore, the answer, the option is actually B. The option is actually B. Therefore, you look at this answer. The answer is B. Right? With that, I think I will stop here. Yeah.